Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled MPDHD, a novel approach to enhance handover process efficiency. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed for the unmanned aerial vehicle where handover is to be processed in the wireless networks while they are moving. So here an artificial intelligence and soft computing based method has been proposed, which is considering multiple parameters in order to decide the handover. So let's move to the video. Before moving to the video, let's talk about that what we will cover into it. In this video, initially we will talk about the application areas that where we are implementing the things, where the things can be useful, and which research people can further use this developed system in the applications. Then we will talk about whatever the code we have designed, how to execute that, what are the software and library requirements to execute them. Then we will talk about what are the current systems, those are working in the same domain and having the problems, and then how proposed system is overcoming those issues and what exactly we have done in the proposed system. Finally, an experimental outcomes and findings has been discussed and will be shown. So let's move to the application area. As I already told that it is related to the wireless communication and for unmanned aerial vehicles. So it is applicable in certain applications like where unmanned aerial vehicles can be implemented. So for safe deliveries, filming, building structures, pipelining inspections, rescuing, surveying in mobile communication technologies where the devices or the cell phones or the users are moving from one place to another for certain application areas and they need to switch to the network. So there the handover decision is very crucial, that it must not lose the connection and multiple handovers must not be there. So in these domains, if you are working with unmanned aerial vehicles or the mobile communication systems, this application area is for you. So let's move to the code. So we will provide you the code. You can see here the folder will be given like this, under which there is a code folder in which all the files has been placed. So the all code is implemented in the MATLAB, so you must have the MATLAB software with you. So you can see here the MATLAB version that I am using is R2019A, so you can use 2015 or the above version in order to execute the code. To execute the code, you just need to go to the folder where the code has been placed and you just need to copy the path, right click, copy, and go to the MATLAB and just paste the path, Control V, enter. You can see all the files those were there in the folder can be seen here. It has three different files that you need to run. One is main code prop, second is dynamic code, third one is user defined mobility. So when you want to run the file, you just need to select the file and click on the run button and it will start executing. So let's run the code. When I'm clicking on the run button, it will start executing a process and each and everything whatever we have written into the system will be done. So now let's talk about that in the meantime, that what exactly we have done. So we do have the base paper with us in which we are following this as a reference paper where they have used handover decision model where feed forward neural network was used. But what we have identified for the work with the artificial intelligence or the feed forward neural network, we need a lot of data set with us for the real-time scenario. Those can assist us to train the neural network. So instead of that, we must focus on making the model those can be dynamic and can be useful by giving some rules and regulations and can identify on different parameters. So the parameters that they were using for taking the handover was data rate, service cost, and signal strength ratio, and the mobility of the mobile devices. And then they were generating the data by their own and then training the network. So what we have identified that in the range of these factors, instead of being using the artificial neural network, why not to go for the neurofuzzy. Neurofuzzy is basically a system which is the combination of neural networks and fuzzy logic. So fuzzy logics is basically, it is a kind of artificial neural network that based on this fuzzy interface system. So fuzzy interface system is basically the system where the user can give their own rules and regulation. Along with that, from those rules and regulations, ANN can train the patterns, train with the pattern itself, and capable to take the decision if any of the scenario that comes other than the rules given by the user. Whereas in the previous models, it was the issue that a huge data set is required to train the network. There is nothing predefined or the rules based system which can assist the ANN to take the decision. So in the proposed method, here you can see the code is running at the back end. What we have done, we have considered 4 of the factor: RSSI, cost, data rate, velocity, and added one more parameter that is termed as load. So in comparison to the previous system, we have increases the factors, then given the number of rules for the neurofuzzy and created the neurofuzzy system and trained it with the different factors and decided that on the basis of that whether how much handoff is to be given or not, right? Then a network structure has been considered, whatever is taken in the base paper. So where the number of users, mobility, the area to be covered, base station location, number of factors has been used. Other than that, the mobility we have introduced with the concept of a random wave model, in which the nodes are moving from one location to another, and in every iteration you can see here we are changing the mobility factor, that at what speed the mobility should change, and accordingly if these factors has been changed, what exactly the handoff count we are getting. So this code start running and calculating the factors by, we are also considering the real time cost 231 model, which is basically a communication model. The reference for those details has been given in the code folder. Here you can see the reference HATA model. So HATA model is basically the communication model. Those are applicable in the real world scenarios where you can calculate the factors of RSSI and other cost and many other factors which we are using in our system. So we are referring these equations in order to identify the parameters. So from the code you can see here we have used the cost 231 HATA model, where we are calculating the factors including path loss, cost, data rate, velocity, and on that we are evaluating taking the decision from the neuro fuzzy, which we have implemented with 5 parameters, that how much handoff should be there. So then finally we are calculating the average of the handoff that we have got for the multiple scenarios and compared them with the existing method. Those results has been taken from the base paper that I have already shown you. Here you can see they have shown the results for different algorithms. So we are comparing that what exactly the results we have given for the handover probability as well as the number of handovers by changing the velocity. So my code is currently running. You can see here it is busy right now. So we will wait for it to get finished. In the meantime, let's talk about the other 2 files. What we have done, this was the scenario which we are using to compare with the base paper. One of the file we have given in which you can give the mobility value by your own. Instead of running for multiple values, you can pass the mobility range, mobility by your own. So we are getting the input from the user, whereas in the previous method we were giving it in a defined form and running for multiple values, so that we will be able to run for the comparison with the base paper. So here you can see the mobility was varying from 0 to 40 with the 5 variation. Here the mobility factor is given by the user. In third of the code, each and everything is quite similar, only we are giving different inputs from the user. So make it dynamic, where you can see you can give the location of the base station, you can give the count of the user in the network, then you can give uh, these factors, and whole procedure will be processed for uh, varying the mobility and other factors, and finally we'll calculate the results and we'll show you the mobility and other related information from the paper and compare it with the base paper. So these are the 3 different files. In each file only the variation is like this is for specifically comparing with the base paper, this is to give by the user for more than 2 parameters, and here only mobility is to be given by the user and rest of the parameters are static. So the code is still running. We need to wait for it to get completed. So here you can see it is processing. Every time the mobility of the nodes is varying. Here you can see the speed of the nodes varying when it is moving from one place to another. Other than that, this is the system that we have designed, where the parameters are 5 in count, having the 3 membership function each. All these are the graphs for the membership functions that we have decided for the system. So currently it is processing for the different mobility speed. So here you can see the results. You can see the handover probability with the proposed method is very less. So this is MPDHD, which is our proposed method, and rest of the methods were the traditional method, where you can see the probability with our method is less. So it means it required less handover if the trajectory and the parameters are to be decided, that whether we need to take the handover or not. This is the number of handover mades with the traditional and the proposed one. So you can see in our scenario, our technique name is MPDHD, where you can see our probability is less, wherever the traditional method was MFBHO, right? So these are the results that we have analyzed from the simulation. So for further modifications are still possible into it. For those details, you can contact us directly and can get the information. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.